Hello guys and welcome to this video. Yuri is here. Today we're going to continue to make our great multiplayer rock paper scissors game. So before we start today's video, let's remember where we left off last time. So we already have a client and the server. Client can connect to server. The players can exchange simple chat messages like here, hello. The message will be broadcasted to every other player connected to the same server. And once there is two players, they will be joined in the game. Once there are two more players, they will be joined in their own game. But right now the game itself is not happening because we have nothing to do with these buttons. And for today, our goal is to make these buttons work. So what we'll make today is the game mechanics, the core game mechanics, except for win and lose condition. We'll leave that off for the next video. So our goal today is to register the turns from the players. And once both players have made their selections, we will tell that the round is over and just print the result of the turns so that players at least know what the other guy selected. Okay, so let's do that now. And before we start making the code changes for this video, let's fix a couple of things that we found in the last video to make our code a little bit better. So here, if you remember the last video, we have notify match starts, the method that accepts several sockets, and it sends the message saying match starts to every socket. The way to do that better in ECMAScript 2015 would be to register REST parameters within this method. So technically, this method could have several sockets, like 3 or 4 or 5, or maybe there you don't know beforehand how many sockets will be there. So in ECMAScript 2015, we've got this REST parameters. And with the help of REST parameters, you register the unknown amount of parameters that will be saved as an array. So sock will be now the array, let's call it socks. So this way, the code looks cleaner, and now it supports not just 2 sockets, it supports any number of sockets at all. The calling method, by the way, do not need to change at all. It can be left off as it is right now. This code is better. Let's jump into the client-side code and add some event listeners to the buttons. So what we want to do once a player clicks this rock, paper, or scissors buttons, we want to send a turn to the server, and this will be a separate type of message. But before that, we need to register an event listeners for these 3 buttons. They have ID rock, paper, and scissors. So let's do that in our client.js code. I create a function called add turn listener. And that function will accept something like ID, the ID of the button that I'm going to alter, that I'm going to add the turn listener to. And how I will call this function, I'll just take button rock, button paper, and button scissors. For each button, I will call add turn listener, like that. So what will be inside of this function? So first of all, I will probably need to have the button itself. Or button equals, I'll get it by ID, get element by ID, and the ID is something that I receive as a parameter, as an argument. Next, I want to add an event listener to this button, and the event type is click. So once this button is clicked, I want to send an event to the server through socket.io. So we used to send the event called MSG, and this MSG event was used for the plain chat messages. This time we want to do something different. We are sending the turn to the server. So in order to distinguish where is the plain chat message and where is the turn, we will send the message of a different kind. So we'll write sock emit, and we'll emit a message called turn. And the value of the turn is ID. Rock, paper, or scissors. We will send the turn as a plain text, just as a text. It could be, in a different game, it could be something more complex, a complex data structure, but in this game it's just rock, paper, or scissors. You could also encode it and send as 1, 2, and 3. Doesn't really change much, but for the sake of simplicity, we'll be just sending rock, paper, and scissors. So now, from the server side part, let's make sure that we can handle these messages. So I'll register one more event listener for turn kind of event, and whenever I'm receiving the turn, I will print this turn to the console log turn. Now it's time to check if our server is working, but one more thing before we restart the server. This syntax is also hidden behind a flag, so you will add another flag to the command line in order to make this syntax work. Let's clear the screen, and I'll start io.js. harmony arrow functions. That's the first flag that we need. And second flag is harmony rest parameters. With these two flags in place, our code should work. Server.js ready to work. Awesome. It's ready to receive connections. Now let's see if the clients are sending indeed the values. Yep, rock, paper, scissors. The values are appearing in console, meaning that the server received them and ready to process them. So this is a half of work, and the second half of work would be to actually implement the game mechanics. Let's go to the server. Remember where we have the code that starts the game. Here it is. If we found the waiting player and we have the second player connected to the server, we are starting the match between these two guys. We could start writing more code to handle the game events right here, but this will not be a very good idea. Why? Well, because we'll have a huge file that does everything, and at some point it will be very hard to understand what this file does because it just does everything. Supporting such code will be a pain. So what we want to do is we want to separate out the game logic into a separate file and have it there. So let's do that. I will call this file RPS game because it's responsible for handling rock, paper, scissors game mechanics. Yes, I want to add it to Git. And the first statement in the file will be use strict because I want to stay in the strict mode. Otherwise, my syntax will not work. Now, I'll introduce the next piece of ECMAScript 2015 goodie, which is a class syntax. Now I can use this class to create a constructor function as well as prototype functions in a nice and easy way. RPS game, that's the name of our class, and immediately I want to export this class so that other scripts like server.js can use it. Module exports equals RPS game. So now let's check. In the server-side code, we need to create an RPS game from require. Here I shall pass the path, relative path to RPS game, starting with // If I do not put // IO.js and Node.js will start looking in node modules folder, not in the local directory. I don't want to do that, so I am putting // and this way the socket IO will start looking relative to the current script. RPS game, I don't have to put .js because this is the default extension. IO.js will figure out which file to import. Okay, now let's get back to this file. I'll create a first function called constructor. Constructor is the function that will be executed once you use RPS game with new keyword, right? So whenever you're creating the new object, constructor will get called. What the RPS game needs to start, it's the two sockets that we use to identify players, socket 1 and socket 2. And let's save the values of the sockets. Sock1. Oh, actually, let's create an array called players and save the sockets there. Sock1 and sock2 will be saved in players. Note this small underscore sign. Why I'm using that? What is that syntax? So this is a code convention to denote that this is a part of private API, of private state of this object. So somebody from outside of RPS game should not try to modify these things or to read these things. You can, of course, because in JavaScript there is no true private field, so every field is accessible. But you should not do that because there is a public API that does not have the underscore in front that you can use to get what you need. So players is the private state of RPS game. You do not really need to get the players outside of the game once you created it. Okay, and since I've got two players, the next logical thing would be maybe to move this part into our RPS game. Notification that the game has started. It's really not a business of the server. It's a business of rock, paper, scissors game. How exactly you are notifying the player that the game has started. Let's build another function called init sockets and call that function straight away. This init sockets like this. Within init sockets, we have to add more listeners to listen to the turn events for this players array, right? Because it's really a work of a RPS game, not of a server, to listen to the turns and do something once the turn is happening. So what I will do, I will run this code again, this players for each. And since I'm on the server, I can use fancy ECMAScript 2015 syntax. I can get a socket and an index, the position of the given socket in the array. And what I can do, I can create a nice little function. that will run for every socket in a list. And first thing that I want to do, I want to emit the message, this guy, match starts. I can remove this function now from here and put it here. So each socket will receive this method. Now for every socket, I will also need to add the listener. So on turn. And in that listener, I will receive the turn itself. And what I'll do once I receive the turn, well, to keep things simple at the beginning, let's just print the turn and the player index. So player index chooses turn, like this. This way I'll just make sure that my code works and I can get the values out of the players. So let's see if this works. And in order to finish our integration between RPS game and server.js, we need to create a new game instance. New RPS game, let's create a new instance and pass our players. So, of course, waiting player, and the second guy is the sock, the guy that has just connected. So this way we have not added so far anything new to this structure. We just refactored, changed the code in a way that everything that is related to the game now is stored in RPS game.js file, and we are not mixing together the server and connection with the RPS game itself. Okay, so now we can remove the code that we don't need anymore, and let's retest our server, see if it still works. Server.js ready to work, looks promising so far. Okay, match starts. We've got the match starts that is now printed from RPS game. So this line has been executed. Now let's see if the turn works, right? So let's get back to our console. Let's open one of our windows and rock. Player 0 chooses rock. Awesome. Now what will player 1 choose? It will choose paver. Player 1 chooses paver. So right now we are registering turns, and the last thing that we want to do, we want to end the round once both turns are there. Player 0 and player 1 have both selected their options, and we can end the round. Let's get back to our small server. In order to tell who won, we need to save the turn selections for both players. So let's create a separate array there. Turns. And we initialize it as empty array for now, because at the beginning of the game nobody have made any choices yet, right? Here inside of this listener, whenever I have the turn, I will need to update this small array and put the choice there. Now unfortunately right now I cannot use the this.turns here in this code. Why? Because this keyword is bound to the current object, and inside of a listener, it will have the different value. It will not have the reference to RPS game itself anymore. This is a known issue in JavaScript, and by the way, in the standard, whenever you are using the arrow function, this issue should not be present. But unfortunately, in current implementation of V8, the arrow functions are behaving with this exactly the same way as the normal functions, which should not really be like this. So without further ado, I'll use let self equals this. And this way I will save as self, and self is not a keyword, it's not a special variable, it's just a normal variable, a reference to RPS game. And using self, from here, inside of a listener, I can refer back the object and get the access to the turns variable. So this will not work, self will work, just because self is not a special keyword. So self turns. What is the turn that we want to save? It's index. So we want to save the turn either 0 or 1. So index equals turn. Okay, we saved the turn. Now, in which case will the game end? Well, when both turns are made. So if self turns 0 and self turns 1 are both present, so they are not null, not undefined. Formatting broke. Then my game will, not the game, but the round will end. And I can send the same message to both players. What I will do, I will have another function called on round end. And here I will send this message saying that the round has ended. So if both turns are made, calling self on round end. Okay. This players. For each player, we want to send a message to his socket of type MSG, which is just a plain chat, saying round end. Something like this. So let's look again at this logic. I have created the new RPS game, and both players are saved in the players array, socket 1 and socket 2. Now I have also the array to hold the turns of the players, right? I'm initializing the sockets, and in this function, what I do for each socket, for both sockets, I have two things. First, I'm saying that the match has started. Secondly, I'm registering a turn event listener, and whenever somebody sends me a turn, what I'll do, I'll save the turn in the turns array, and if this is the second turn, right, if both turns are made, I will say that the round has ended. And also I'll probably send the turns themselves to a player. So I'll do text, and let's put it that way, round end, results, and I'll use this turns join to have a nice string out of the turns, right? And this way I will send the both results to the clients. So instead of emitting round end here, I'll emit this nice text. Okay, awesome. So this is how we will tell the players that round has ended. And of course, once round is ended, we need to clear the turns to start the next round. Okay, now this is a basic logic. Let's try if that actually works. I'm not sure. Should work. Ready to work. Let's refresh our clients just to be sure, even though we haven't really changed anything. So the first guy selects rock. The second guy selects rock, rock, and round end results rock, rock. So it looks reasonable. Scissors and paper results paper, scissors, paper, scissors. So now we have a game that is already playing in rounds, and it sends back the result of the round. Now the only thing that we have to finish before the game can be actually playable is to implement the rules of endgame, to define who won and who lost on the server. We'll do that in the next video. So stay with me. In the next video, we'll clean up the code a little bit further and we'll implement the endgame mechanics. See you then. Thank you for watching.